Vericom is the most modern instrument available for traffic accident investigation and reconstruction in the world. It is used by the experts at Northwestern University Traffic Institute and at the University of Florida Institute of Police Technology and Management, and thousands of other experts. When you receive your Vericom, the user type is set to General. Change the setting to Accident Reconstruction. Go to Tools. Scroll down to Setup. Press Enter. Scroll down to User Type. Press Enter. Scroll up to Accident Reconstruction. Press Enter. Press Clear twice to get back to the Ready screen. You may also use Profile to change setups. When mounting the Vericom in the vehicle, mount it in the direction of travel. The best way to do this is to mount the Vericom in the center of the windshield because the windshield is curved, and mounting it to the right or left of center could cause a cosine error. In the default mode, with G-summation 3D selected, the Vericom does not have to be level to get accurate results. You can tilt the unit in any direction for easy visibility. Drive to the scene of the accident. If you zero adjust on the slope, the Vericom's average G-force will be the drag factor. Turn the unit on and press the braking button. The Vericom will zero adjust for the slope. Position the vehicle about 300 feet before the accident. When in position and ready to start your approach, press the Auto Start button and accelerate to your target speed. Suggested speed for ABS brakes is 45 miles per hour. For vehicles with standard brakes, it is 30 miles per hour. After you have reached your target speed and you are at the scene of the accident, slam on the brakes as hard and quick as possible, bringing the vehicle to a complete stop. Refer to the braking section for more details.
And we have you do an acceleration run between two speeds. And the application for that is you're out here in one of these smaller roads and divided highway and 55-mile-an-hour zone, and somebody pulls out to pass, and boom, about 75 miles an hour they get into a crash. So you want to know the average G between 55 and 75 miles an hour. Okay? You can program it for time. So we time it for 3.5 seconds. Suppose you know it took that person to walk out into the street, it took them 3.5 seconds, and you want to know how far that car could accelerate in 3.5 seconds. So, or how fast it could be going after 3.5 seconds. That'd be a good application. And then this is a cool one here. Just start at 0, and we're just going to program this thing for 12 seconds. And we'll start at 0, accelerate to 45 miles an hour, and slam on your brakes to come to a complete stop. And then we're going to get acceleration and braking. We have to go to the graph to get this data. But if you had a vehicle and you had to give it back to the owners, and you don't know, somebody went from the accident, they went to a hospital, you don't know if they died, you don't know if it's a fatality. 6 months from now, they might ask you to reconstruct the accident, the vehicle's gone. If you only got one shot to test a vehicle, this is a good thing to do. And we're going to show you how much data you get out of that after the fact. Another application we got for it is you're at a stop sign, the accident is after the stop sign, let's say it's 100 feet after the stop sign, all right? So if you don't have a Vericom, here's what you're going to be doing out there. Maybe you got another way, but this is what they tell me they do. You're going to be sitting out there counting somewhere between 20 and 100 cars a day, with your stopwatch and watching them go and trying to get some sort of acceleration factor with them. That sound like something you might do? Okay. With the Vericom, we put it in the vehicle. So we come to the stop sign. We program it to go 132 feet, push the auto start button, we accelerate. How far do we accelerate? We don't know. We just keep going till the Vericom tells us we went 132 feet. Once you get to 132 feet, it'll beep and turn itself off. And then we have the speed, time, distance, and average G from 0 to 132 feet. While we're out there, we're going to do 2 of these exercises. One will be at hard acceleration. Purpose of that is to find out what the maximum speed of that vehicle could have been. Let's say it's a shorter distance, 50 feet. Speed limit's 35 miles an hour. Could that car get up to 35 and 50 feet? I don't know. Test it, okay? But more likely what you're going to want is average acceleration over that distance so that you have the time it would have taken a pedestrian to walk from the sidewalk out to where they got clipped.
The Vericom has an accelerometer for measuring lateral G. This feature can be used for measuring the vehicle's cornering ability, critical speed yaw, or lane change formulas. To do this, G summation must be off, so that each of the axes is displayed separately.
Just go in a straight direction there, and just like you were going to make a lane change out on the interstate, go from right to left, and then come back and go from left to right. If you make it just as you might normally, and you'll end up pulling about 0.1, 0.15 Gs in, and then when you come back, do it more aggressively, and then you'll probably be around 0.4 Gs average then. If you're solving for speed, the difference between 0.1 G and 0.4 Gs doubles your speed. So that's the difference between 30 and 60 miles an hour. If you have your speed and you're solving for distance, the difference between 0.1 G and 0.4 Gs, it doubles your distance. So you're going from 200 feet to 400 feet.
Vericom Continuous G Graphing Mode shows the lateral G forces for left and right turns in real time.